Something that very few people know about the dynamics of the Allied bombers in the Second World War were the strange countermeasures that they used to be able to deceive the enemy anti-aircraft systems on the ground, and they really ranged from complex radio frequency systems to deceive enemy radars to even such bizarre countermeasures that consisted of simply throwing straw or bottles to confuse the enemies. Today we will talk about these strange countermeasures, from the most conventional to the most bizarre, that the Allies had to develop during the course of the conflict in order to be able to return home alive and tell us the story. Nowadays, detecting aerial targets is a highly automated and relatively simple task, despite the presence of stealth technology. However, detecting aerial targets was an absurdly complicated task back in World War II. They were in their infancy, and almost all of the work depended on human eyes and ears. At low altitude, detecting an enemy plane was not a problem as they were visible to the naked eye. However, the Axis and Allies had anti-aircraft systems that could detect targets over 90 miles away. And more importantly, these operated at any time or in any weather. All this thanks to the radar systems in Germany. These were very advanced for the time. However, usually either having a radar director or a radar itself was not so common in the Second World War for the Germans, and much less in Axis countries like Italy or Japan. In addition, by the middle of the Second World War, the countermeasures used in the bombers were so technologically advanced compared to the Germans that the radar systems often became completely ineffective. This made the presence of the old and reliable reflector mandatory to detect enemies in the darkness at that time. Basically, the Germans and Japanese had 4 systems to detect enemies. Obviously, we have the popular radar. The radar could operate in any weather, and at night, basically by emitting radio waves and receiving those that bounce off the enemy plane, to in this way, through calculations, determine if there is an object and where it is constantly going. If the radar failed in the same way, there were other methods to detect the planes. They were the sound locators, which through the sound emitted by the plane were able to obtain its height and direction. Basically, they worked like a huge common stethoscope and even operated with an analog computer. Thus, they calculated the height through the sound of the plane. Probably those who used these systems the most were the Japanese, who surrounded their cities with these to protect them in combination with other systems against them. However, for the final stages of the conflict, the Americans developed very effective countermeasures to confuse to the sound locators, and thus disable them. Another very popular location system for its simplicity was the stereoscopic rangefinder, which was very good at detecting enemies at low and medium heights, detected enemies through optics with one or several operators obtaining data such as the direction or the angular height of the enemy to send them to the director, who was the machine that did the calculations. But the stereoscopic rangefinder could not operate in bad weather or at night, and that's where the light reflectors come in, which were basically completely essential at night. They were used as low-altitude anti-aircraft weapons. Detecting enemies and their use was phased out. Rising for the conflict's final stages, all these methods of target acquisition were susceptible to countermeasures. For example, radar was defeated by methods as cutting-edge as they were bizarre. Normally, jammers or radio frequency emitters were used that sent radar signals on the ground so that they would get confused and send erroneous data to the batteries. There were also quite strange methods like literally throwing straw. The straw as a countermeasure, or better known as chaff, were strips of aluminum, or literally straw, that were launched in huge quantities over enemy radars. Each aluminum sheet was as thin as paper, and it came packaged in small packets that were launched from windows in the bombers. Later, special small compartments were made to launch them more comfortably by the Royal Air Force operators. The clouds of aluminum straw made the radio waves bounce off them and intensify them in such a way that the radars interpreted that the straw clouds were huge objects, or directly the chaff clouds dissipated, the radio waves making it impossible to see anything above them. The chaff was used in a reduced but uninterrupted way by the Royal Air Force of England until the end of the conflict. Sound locators could also be easily fooled. These methods greatly depended on the consistency of the sound of the bombers' engines. It was easy for the bombers to fool these anti-aircraft systems. As long as they passed through an area where it was known that these systems existed for a bomber to fool a sound locator, they simply reduced the engine power and glided a bit more, or also accelerated the engine irregularly. Another quite bizarre trick that was used at this time to fool the sound locators was to throw open bottles into the air near the sound locators. The falling bottles generated a very characteristic whistle that confused the operators and stopped the detection, as the bomber crew in the Pacific campaign report. When throwing bottles at the anti-aircraft systems, they simply stopped attacking for about 2 minutes. That's how long it took for the bottle to fall. They even turned off the spotlights to isolate the sound of the plane to fool the stereoscopic altimeters. It was easier to attack at night, and at high altitude they didn't have the ability to detect anything, since the planes simply weren't in sight. But normally spotlights were used to detect the planes in flight that were guided by radar, or by the sound locators. Their silhouette formed by the light made it very easy for the defensive fighters to see them. The most common German spotlight had a 150-centimeter lens, and it emitted a light of 990 million candles. It had a range of 5,000 meters. The largest one had a 200-centimeter lens and emitted a light of 2,400 million candles. It had a range that reached up to 8,000 meters. However, spotlights like these, regardless of their size, also had many countermeasures used by the Allies to defeat them. A very popular and widespread one was to paint the underside of the bombers shiny black. When the spotlight was pointed at the plane, the non-reflective paint made it impossible to see in the darkness, so that no vision-based method would be able to detect it. Another countermeasure against the spotlights was to literally attack the spotlights. The spotlights were good for seeing the enemy, but the downside was that they revealed your position for miles around. In the Pacific, it was common for bombers at altitudes of 1,500 meters to attack the spotlights with defensive Browning 50 caliber machine guns, usually causing the Japanese to turn off the spotlights to avoid being attacked by the bombers. As you can see, even though it sounds crazy, all these countermeasures were tested by the bombers, and having satisfactory results, they were recommended by the same High American Command to be used by all the bombers in this conflict. Whether it was complex radio frequency countermeasures or literally throwing bottles at the enemy, all of these contributed greatly to the Allied victory and ensured the Axis defeat. Thank you very much for this video, and see you next time. Goodbye.